Testing, testing, check, check, check. Okay. Let me get this volume turned up a little bit. Hopefully that'll be good. Go a little bit down from there. A little bit. Okay. Alright, that should be okay. Cool. Apologies for the late start today. Having some serious lag issues when I started the stream, and I had to kind of restart everything. I think everything is stabilized now. It appears to be working correctly, so hopefully things will be okay. I'm just going to post in DS Basic Prep real quick. Okay, and let me pull up that channel, that thread, excuse me, on my phone here so I can keep a monitor on things. Alrighty. Cool. Let's get started. So feel free, as usual, to, if you have any questions, whether those questions are from Learn or from somewhere else on the internet, just so long as they're in the scope of Learn, so long as it's bite-sized enough that I can take the question on stream without it, taking up a huge amount of time. Yeah, so feel free to bring in your Python questions, put in your problem statement and link to the problem, and any code is optional. If you have any code that you want me to debug or help you troubleshoot, you can pop that in as well. Since I'm not seeing any questions yet, I'm just going to jump into wherever we left off last time, which looks like, let me make sure I'm on the right thing. Basic prep, this will do. Looks like we left off on list functions and methods last time. So we'll just be going through this until I see some questions. Okay. Well, looks like we did this one. We've got somebody who's saying that they're a first timer for the study halls. Well, welcome. Yeah, feel free if you have any questions. It doesn't look like anybody else has brought anything, so you're welcome to ask something if you've got anything you're going through. We can go through that. It looks like we already did list methods stuff, so that just hadn't updated for some reason. I'm not sure why it said I had one more there. We'll go through this. Okay. Looks like we left off on traversing a single nested list, although we do have a question, so let's take that. So we've got, hey y'all, how can I add each index where the vowel occurs in a string? My code returns the last index. However, I need all the indices where a vowel occurs. Okay. This looks like a problem from Learn to the poster of this question. Can you please, if there's a like a formal problem statement, can you post that and a link to the question? I think I have enough information to take it here, but I do want to just be able to provide the proper context with everything. So let's see. This is the question as it was asked. We do have a two-space indent here, which I'm going to just rectify really quick. Oh, that's going to give me problems, because of course it is. Let's do this. Okay. There we go. Okay, so I'm just going to give this a quick read, and we'll run it. Actually, let's run it first. So we've got result equals an empty dictionary. Excuse me. Sorry about that. Result equals an empty dictionary. List underscore equals a list of each word, or of the word, I guess. I'm not seeing list underscore used again. So I don't think that that's coming into play here. I don't think we'll need it. And we have for the index and I, which is presumably the element, the character in the word. If I equals A, or I equals E, or I equals I, or I equals O, or I equals U, or I equals Y. There's a quick and easy way we can shorten this. We can do a check for membership, and we can say if I in A, E, I, O, U, Y. Now these are all lowercase. So since Python recognizes uppercase values as different characters, right? So, you know, for example, here I'll just print this. I'll print this down here. Actually, let's just look at an example here. Print A equal to A. Oops. This is going to be false because lowercase a is not equal to uppercase A according to Python. So if we do, let's just switch them here just to kind of model the order a little more. Or let's actually do it like I'm doing up there. We'll say capital A and A, E, I, O, U, Y. Well, excuse me. We'll actually do a check for membership, which is what I intended to do. This is going to be false. Whereas if we check for lowercase a, that's going to be true. So what we have here, I'll call it C for character. C is a character. If I have character equal to uppercase A, I do want it to be true when it's in here. So I could add in the uppercase characters, or I could say C.lower, and that'll give me a lowercase version of C. So that'll be true because C, which is character, which is equal to capital A dot lower is lowercase a, which is a member of this string A-E-I-O-U-Y. So what I'm inclined to do here is say if I dot lower in A-E-I-O-U-Y, then result sub I equals IDX. So right away, here's what I notice. We're going to get a dictionary. We've got a good test here, which is cool. So we've got my dictionary word, right? So if we look, like Y occurs in more than one place. So that means presumably that our values have to be able to reflect all of the indices, not just one index, which I think is, that's the heart of this question, right? However, the value is an integer, which can only reflect one index at a time. If we wanted to reflect all of them, we might want to include them in a collection type like a tuple or a list. I think a list makes sense here. So what I want to do here is say if I.lower in A-E-I-O-U-Y, what we want to do is we want to add I as a key in the dictionary only if I is not a key in the dictionary. We want to add it in. So we'll say if I not in d.keys. So if I is not a member of the keys of the dictionary, we'll say result sub I equals, that'll be our dictionary, sub I, equals an empty list. And then whether or not it's in there, if it's not in there, we're going to add it in. If it is in there, we're not going to add it in. But either way, whether we added it in or not, after we add it in, after we check if it's added in or not, we're going to result sub I dot append IDX. And that should give us a dictionary with vowel keys and list indices. Oh, I always call my, when I do like an output dictionary like this, I always call it D, but this person called it result, so I'll call it result. This is from adding key value pairs in the, sorry, can you actually send a link to this? It'll take me a minute to actually find it manually. So if you can just copy paste the link rather than the instructions on how to get to it, that would be helpful. Thank you. Okay, cool. Good. So we have y shows up at index 1 and index 12. Let's see. So that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Good. So 1, 12. That's close enough for me. I still don't have a, oh, sorry. Here is a link. Thank you very much for the link. That is helpful. Keeps things nice and smooth. All right. Adding key value pairs, and this was number 3. Which looks like it's going to be here. This looks like the code I submitted before. I suppose I'd done this one before, so we'll look at that in a second. Oh no, here was the link. I just pasted the link. I wanted to paste this. So real quick before I pop this in, I do see this list underscore equals list of word. And this just isn't being used anywhere. I don't see list underscore being used anywhere. Perhaps this was just some code from a previous attempt that was just left in here. That's what I suspect, which is fine. Nothing wrong with that. Like you're working through something, you kind of got some leftover code, whatever. It's not a critique. But just in case, I look at this and I also wonder if perhaps the reasoning behind this is that this would convert Word into a list somehow, which I think is probably not what the assumption is, just reading this code, seeing where this person is at. But just in case, this is not going to, this will give a list of all the characters in the word as a list of individual characters and assign it to this variable, but it won't convert the word in place, right? Just in case that was the idea. So the word, we can pass the word itself, which is a string, we can pass that to enumerate. We could run through it directly in the for loop, which would work. Just sandboxing, okay, yeah, that's cool. Yeah, so this person is saying they're just sandboxing and, yeah, trying different things out, presumably, which is my assumption. But just wanted to make that clear if anybody was reading it that way or if that's where that was coming from. So, good. Okay, we'll save that and paste that in. I think this is the same solution I had before, essentially. So it looks like it accepts that. And let's look at my previous solution just because, I don't know, we're here. So I called, looks like, I don't know, if I named this. Right, a function called letter IDX that will track the indices of where the vowels occur in a string. The function should take a word or a sentence. So I just called my argument sentence, I guess, which is like whatever. I mean, same difference. Returns a dictionary with keys representing the values that occur in that sentence, and the values of that dictionary representing the indices where that vowel occurs in the word or sentence. It doesn't actually say, it just says the values representing the indices. So it's not explicitly asking for a list. I think the idea with this is that they want you to infer that the values of the keys of the dictionary should be lists. That's what I'm gleaning from that. Oh yeah, and then this shows that as well. So for this exercise, y is considered a vowel. So this is an example that actually confirms what I was. They're not saying explicitly, but they're showing that, for example, for this call with hello there, this is the output. And what we can glean from this output, a lot of times when you're working with a dictionary, a function that returns a dictionary, it's really, really helpful to draw up or just write up a really quick schema. So for the dictionary, so I always call this a schema at least. What a schema is just something that tells you how the dictionary is structured, right? Doesn't need to be specific, doesn't need to be in formal, proper code or anything. A lot of times what I'll do is just do the sort of the types. So I might say, so my schema for this will be a dictionary, and I'm going to do a kind of a notation that this is sort of a notation that I use where I'll just give a word that, or like a sentence that'll describe what I'm after here. So vowel, and then in angled brackets here, I'll say the type, so which will be str. So vowel is a string representing the vowel, colon, so that's going to be my key, and then this will be my value, will be a list of, and then I'll say indices. I probably spelled that wrong. Let's see. I did. Okay. So that'll be my indices, which are going to be integers. And since I see this in square brackets, I know it's a list, but you know, if I wanted to be thorough, I guess I could say list here, but I can tell that that's a list. And this is just my own notation. So your notation might look a little different, but if you're looking for, like, you know, this is the way that I would do it. Because to me, this gives me the information that I need to remember. While building this dictionary. This tells me the sort of structure that I'm building towards, right? Which is the keys are going to be strings representing the vowels in the word, and the values are going to be lists. If I really wanted to make that clear, I guess I could put list here, you know, do whatever you want. And the contents of the list are going to be the indices, and maybe if I wanted to be more descriptive, I could say vowels indices. Vowel indices, which are going to be represented as integers. So we'll have a list of integers. We could even say list of int like that to be super clear. So this is just an example of a schema that you could write, or you could write it in a lot of other ways. But just so long as you're being clear about basically at least the types of data you expect for your keys and your values. That's always a helpful thing. Cool. So anyways, this kind of shows us that too, right? In a small problem like this, I probably wouldn't be this thorough. This dictionary is simple enough that I wouldn't need to like go through all this trouble to type it out, but it might help if you're ever having that notion of like, if you find yourself asking, what am I trying to return, like more than once, then probably just write a schema. Like I said, it doesn't need to be formal. Mostly it needs to give you an idea of what the types of the keys and values are. That's kind of the sort of central piece of information that I'm looking for. And this shows us that string key with vowel and the a list representing the indices. Good. Okay. Rant complete. And that again. Oh, you're welcome. Cool. Glad that was helpful. That was a fun one. We've got another one. Our first timer is asking about for loops is what I'm stuck on, but don't have a specific question. Okay. I will bear that in mind and sort of pay special attention to for loops as we continue. I guess, I mean, this question has a for loop in it. Why don't we just look at this for loop really quick, just give this a little extra context. So a loop just allows us to run a body of code, the body of code within the loop, which is going to be this code here. It allows us to repeat it however many times, right? So in this case, our loop is iterating through this word. We're enumerating the word, which means that we're going to get back not just the character of each word, but enumerate is going to give us the index and then the character. So we can say, we get to name two identifiers here, so we get to give a name for the identifier for the index and the identifier for the character. In this case, I didn't change the variable names here. I'd probably call I probably call it C or CH because it's a character in a string, and to me C or CH says it's a character in a string. I mention this every time I talk about short variable names or single letter variable names. I do encourage people in general to avoid super short or single letter variable names unless there's a standing convention for what that variable means, right? So not unless either there's a standing convention or it's somehow obvious, at least obvious to you. Like, I don't want to exert any like effort in thinking about what this is. To me, CH says character, you know, like I look at that and it says character. So that's easy for me to read. If it's at all difficult, give it something more descriptive. That's the sort of the rule of thumb there. But yeah, so this allows us to name, the enumerate will allow us to name the index and the character, and then execute this code. And each trip through this loop, index and character are going to be updated appropriately. So index is just going to be advanced to the next number, and character is going to be advanced to the next character in the string. Cool. Do feel free to ask any further questions if if we're working through something and I'm taking something as a given for loops. Feel free to be like, hey, what do you mean by that, or whatever. So Yeah. All right. Looks like we've got. I like the schema technique. I'm very visual, so the idea helps. Awesome. Yeah, that's good. I noticed, like, I just started doing it out of necessity, out of just like because I was writing a bunch of code and I realized I kept doing this thing, which is I'd get like 15 lines into something and then I'd go, wait, what am I doing? What am I trying to end up with? Where am I heading with this? What is the type of the key again? Or like one thing or another. And this was sort of the impetus behind my like sort of vigorous attention to testing in general. And I consider this part of testing, you know. But when I start a problem in general, I mean, if the output is complicated at all, if it's any, you know, a list or a dictionary that has any complexity at all, I'll just jot down a quick schema, just something to give myself. Like I said, this is pretty formal looking. I wouldn't be this thorough with something this simple. I'd probably just do something like stir list of int, something like that, just to be a quick reminder. But just some sort of note, you know, that way when I when I'm, you know, 10 or 15 lines down the wrong path, or maybe like one line or a half line down the wrong path, I can just glance down here and just have a quick, easy reminder of like, oh yeah, that's where I'm heading. And you know, this print line is in the same spirit. But when I start a problem, this is the first stuff that I do. Like I do this stuff before I do the definition, because to me, you know, like having this in place makes defining the process so much easier. If I know what I'm starting with and what I want to end up with, you know, and maybe I would want to add to that something like what it needs to do in the middle, you know, just like a quick description about what it needs to do, then I can implement it really easily. Cool. All right. Cool. Also, we have a comment about next time I'll come with detailed questions. Awesome. Your questions don't need to be detailed though. If you're just having, even if there's just a problem in Learn that you just like want to see a solution on, or want to get my take on, you can just be like, hey, you know, what about this one? Or just throw me a link, and that's all I need. But yeah, of course, you know, be as thorough as you want to be, but not required. Pretty casual environment, really. All right, cool. Looks like we got a couple more questions here. Let's see. I'm worried my audio is peaking a little bit. I'm gonna turn my mic down a little bit, so let me try to do this. Check. Okay, that seems like it might be a little cleaner signal. Apologies, these headphones are really on their way out. I have some better headphones in the mail. They'll be here in a few days, so that'll be fixed. Okay, let's move on. Come on. Having trouble with the enumerate function. All right. Enumerate's a tricky one. Write a function called alt series. I think I remember this one. Okay. This looks like the copy from the problem statement. I'm not sure if that includes their code. This is, not sure which problem this is. Oops. Okay, we'll just look for the one that says something about alt series. Probably the third one. Okay, yes. So here's my previous code. We'll just comment that out and don't look at it. Here's the problem statement. I was asking for the problem statements to be posted. I realized I don't need the problem statement to be posted in Slack. Apologies for, you know, if that makes it sound like I need that. I really just need the link and the like. If you have any code you want me to go through, you know, but mostly just the link so I know where to go. But not that there's anything wrong with pasting the problem statement either. Just wanted to give some context to that. Okay, cool. Write a function called alt series. This function should have one parameter, which will be a list of numbers. So while I'm reading that, if you'll notice, the first thing I do here is I just yank these tests out of the example where it says example. I'll just get rid of that. And I'm just going to put those here. Where it had the arrows, this is sort of a common formal shorthand for return. So this is like saying should return this. So this call should return that. I'd like to just comment it out, and just so I take a note for this input, for this specific input, I expect this specific output. And then just so I can actually verify that that's what's going to happen, we'll just print. All right, I'm just putting some space in here so it's a little more visually readable, you know, so we can see where this call ends and all that a little easier. But the spaces aren't semantically or syntactically required. They're just for me to make it more readable. Okay, so write a function called alt series. The function should have one parameter. There's the parameter. So def alt series. One parameter, which is just a list of nums. What does it say? Will be a list of numbers. Well, there you go. Num list seems like probably a good name for a list of numbers. We'll just return for now. I don't know what I'm returning, but we'll get to that. This function should, in a variable called altsum, I remember this. So this is in a variable called, let's put bullets here so I can kind of isolate these. This will be altsum, powsum, idxsum. So we're going to have these variables. It wants these specific variables. I think I'll do this and this. It wants us to return these, I think, in this order. So I've done this one recently, so I think that was it. Now we'll just boom, boom, boom. All right, and then what does it want these to start with? Altsum will sum together all the numbers. Sum together all the numbers in num list. Where the values with even indices are added and the values with odd indices are subtracted. So the values, that's the values. Okay. Yeah, so I think all of these are going to start at 0, actually. So I'm just going to appropriate one of these return lines, and we'll just, oops, I don't know how that happened. We'll say all this will equal 0, 0, 0. We'll start all those at 0. This is saying the function should return these three variables in the order altsum, powsum, idxsum. Altsum, powsum, idxsum. Confirmed. Good. Okay, so we're just setting the stage right now. I'm not even really doing any problem solving. I'm just writing down everything that the problem is telling me. So I have some tests with some specific inputs. These lists are specific. They're not another list. It's definitely this list with 2, 4, 6, 8, whatever, right? And it's telling me what I should expect here for the output. And the same thing with this. So I have my tests. These are, in essence, also my output schema, which is just a tuple containing these three numbers. It's enough of an output schema for me. I guess I could write like tuple int or something, but I don't know. Seems a little frivolous. But you might want to do that too, There's times where you might want to do that. Okay, so what I'm seeing here is we're doing a different kind of summation on each of these. So it's like these are each an accumulator, and we're accumulating differently onto each of them. But we can do that accumulation in a single loop, because in any case it just involves going through each element of the initial input list and gleaning the element and the index, meaning naming or putting an identifier to the element and the index for each one and doing something with that. So I'm just going to do this like a checklist. We're going to do this one, we're going to check that, we're going to do the next one, we're going to check that, and we're going to do the next one. Okay, so like I said, for loop for num and num list print num. Okay, just get our for loop up and running, run our code. Looks good. I'm getting 2 outputs here, which is fine. I guess I'll keep both outputs. So I always like to just print my identifier, just throw a simple for loop down just to get me started. I remember now I do need the index. So for me, here's the thing. If I'm working through a problem and I'm like, okay, I've got to go through all the elements in this collection, whatever, if it's a string or list or tuple or dictionary, whatever, all the elements in the collection, I guess not a dictionary for this specific thing, and I think if I have the thought, I need the index, I need access to the index, or what's the index, if I have something along the lines of I need to know the element and the index, instantly I know. I don't need to think about anything else. I know that I need to enumerate. And sometimes if you ever have the thought like, do I need to enumerate? Just enumerate. Like the worst thing that's going to happen is you're not going to use IDX and you didn't need to enumerate, and you're still going to get to a working solution, and you didn't waste time thinking about whether you need enumerate or not. So since I know I need the index, I am actually certain that I do need enumerate. So, or there's other ways to do this without enumerate. We could do like a manually incrementing index, but kind of not necessary. Enumerate's such a better and more elegant tool for the job. Okay, so like I said, we're just going to checklist this. Start with the first one in a variable called altsum. Sum together all the numbers in numList where the values with even indices are added and the values with odd indices are subtracted. Okay, so now what we have to do is we have to see if the index is even, then we're going to add the num to altsum. If the index is odd, then we're going to subtract the num from altsum. So think about this, and like think about how would you tell if index is even? How would you add num to altsum, etc., right? want to give folks a second to just chew on it for a second, see if there's any initial impressions, moments of inspiration. So what I can say is if IDX, so if I divide IDX by 2 and I have a remainder of 0, then I know it's divisible by 2, which means it's even. So the way I can tell if I have a remainder of 0 is that I can say if IDX modulo 2 equals 0. Modulo is the remainder operator. So if the remainder of IDX over 2 is 0, we'll say alt sum plus equals num. Then we can say minus equals, and we'll just do else. We'll just do else there. So if it's even, we'll just say, we'll make a little note here, IDX is even. Otherwise, if it's not even, it's odd. So IDX is odd. So if it's even, we add to alt sum. If it's odd, we subtract. Okay. So I'm going to run it, and we'll see what we're getting for alt sum. So notice we should expect 4 and 0, since alt sum is the first thing being returned here. We should expect 4 in the first position and 0 in the first position. Looks like we have -4 though. That's not quite right. I seem to recall something about this index. See, I didn't read the notes. Of course. So here we have the notes. Recall that in order to return multiple values from a function, you can simply separate them with commas, which I did here. It should be like bulleted or something. I don't know. So that's one thing, and then another thing is the summation index should start at 1. So enumerate takes an optional second parameter, which is where we want the indexing to start. I want it to start at 1 because this says the summation index should start at 1. Before it was starting at 0, so if that's the case, then it's going to be subtracting the ones I want to add and adding the ones I want to subtract, which seems feasible that since I'm doing it backwards, I'm getting the number, the negative version of the number instead of the positive version of the number. So now that I've fixed where the index is starting, let's see what I get. Now I get +4 and I get 0, +4 and 0. Okay, good. Looks good. Okay, in a variable called powSum, sum together the result of raising each value to the power of its index. This should be easy. So we'll say powSum plus equals the product of num to the power IDX. And then I remember the last one is just this in reverse, IDX. And I think this one's called IDX sum. Yeah, that's IDX sum. Okay, let's just try those out. See what we get. So for this first one, I expect 4, 4, 3, 3, 0, and 6, 6, 2, 8, 2. I get 4, 4, 3, 3, 0, and 6, 6, 2, 8, 2. Good. So this first test is passing. Let's see about the second test. The second test I expect 0, 4, and 10, and I'm getting 0, 4, and 10. Excellent. Oh, okay. We have some confusion. Where's this point of confusion? We started the index at 1, so did it skip to? Oh, yeah, no. So this is a good question. I think I'm getting where you're saying, what you're saying here. You're asking, since we started the index at 1. I'm just making sure I understand what you're saying. Since we started the index at 1, did we skip this first element? Did we skip iterating over that and like literally move to the first index? All this does is this doesn't change where you start iterating from. This is a bit of a stretch of the idea of index, honestly, because it's now no longer really the index. What we've done is basically just saved ourselves from having to do IDX equals IDX plus 1, right? So that's just going to adjust, it's just going to modify the value of IDX. It's not going to change where we start or what elements we iterate through. Does that help? Let me know if that helps. Sounds like that was your question, so that's good. Yeah, so we're still gonna go through all the same nums no matter where we start this quote start the index. That is kind of confusing. I take it as a given, so apologies, but yeah, we're not gonna start in a different spot. It's just gonna sort of like think about it like calibrating the index. Like we can adjust it wherever we need it. It literally just starts at the number 1. Yes. So instead of starting at index 0, it literally just starts at number 1. Yes, that's correct. But yeah, but at the first iteration, yes, it'll still so IDX will be changed, but num, the values for num will still be 2, 4, 6, and 8 for this specific list. This is a really good question, by the way. Cool. We have a request for, can I remind why we use the plus equals and minus equals in this problem for alt sum plus equals num and alt sum minus equals num. Yeah, okay. I'll touch on this again. So this is what's called syntactic sugar. What syntactic sugar is just, it's syntax that just makes something a little sweeter. It makes something a little nicer to do. So what Python looks at this and it turns this line, it literally behind the scenes rewrites line 50 to look like this. Alt sum equals alt sum plus num. So it literally takes this and it turns it into this. So these two lines are in every way equivalent. They are absolutely equivalent. The reason we have the plus equals and minus equals, you can also do times equals, divide equals, mod equals, floor divide equals, any of the operators you can use in this manner. The reason for that is that this, x equals x plus y, that pattern is so common that the Python developers just thought that shortening it this way would just make it a little more elegant and a little easier to deal with. So what's happening here on 51, just for context, this is saying, or on either of these, this is saying modify this according to its current value, right? So, take its current value and add or subtract whatever from it. So, yeah. If we want to subtract num from it, we say minus equals, or we could say alt sum equals alt sum minus num. If we want to add num to it, we could say alt sum plus equals num, or alt sum equals alt sum plus num. So this is like saying the new value of this is equal to its old value plus whatever. So hope that helps. We also have another question. Do I have a link to keyboard shortcuts that I recommend? Specifically, how do you select multiple items at once to edit, move, or delete while you code? Well, I don't have a link for that because we recommend that you use VS Code. I'm going to recommend that you use VS Code. I don't, however, personally use VS Code. This is Atom. This is the sort of VS Code's ancestor. Atom uses different shortcuts, and then what I do is I customize whether I'm using Atom or VS Code. I have VS Code installed, but I personally prefer Atom because that's what I learned on, and it's like my baby. I just love it. But VS Code is really the industry standard, and that's what y'all should use. So your shortcuts are going to be different. I customize my shortcuts in kind of an extreme way. So they're not really going to be they're not really going to apply. But let's take a look at this. Let's do top 10 VS Code shortcuts, keyboard shortcuts. VS Code tips and tricks. And it's going to be different for your platform. Obviously, I think this one's talking about Windows. Of course, VS Code is developed by Microsoft, so that just might be from Microsoft. 15 VS Code shortcuts. So the nice thing too is if you're using Replit, which is where we recommend you start before you have VS Code all set up, Replit uses VS Code shortcuts. So any shortcuts you learn for VS Code will work for Replit as well, which is pretty rad. Let me see if I can find the ones. Add cursor above, below, cursor to line. What is this one? Shift Alt. I don't know. That's kind of a weird one. Yeah, I don't know. Honestly, I would just Google around and just look for useful shortcuts. One that I think the multiple line selection, I think the one I use is the same in VS Code. Or yeah, it is because it's the same in Replit. And this is probably the one I use the most, that I get asked about the most. So let's say I want to change num here to number or something. So what I can do is I'll just put my cursor on the left or the right or anywhere in the middle of the thing, just adjacent or somewhere in or on the thing I want to select. And then I'm going to hit, I'm on a Mac currently. Usually I'm on Linux, but if you're on Linux or Windows, I think it'll be Control D. For me, it's Command D if you're on a Mac. So I'll hit Command D, and that'll just highlight whatever word it's most adjacent to. And then I'm just holding Command and just tapping D until I have the rest of the ones selected. So Command D, I'm holding Command D, 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 and that'll select all of them, and then I can do whatever I need to do. And then when I'm done, when I don't want multiple cursors, you can just click somewhere, or you can just hit Escape, and that'll put your cursor back where the initial cursor was. So it's probably one of the most useful tricks that I do. Another one is line duplicate, which for me is Command Shift up and down, although I think I changed that one. I definitely changed it from from Adam's shortcut. I'm not sure if I changed it to VS Code's shortcut, but line duplicate is another one that I use all the time for duplicating lines. So, yeah, something like that. But yeah, really, I would just say just go Google around for like useful. You do top 10 or like VS Code keyboard shortcuts, and then like maybe your Linux, because I like Linux, or whatever your operating system is. So sorry to be a little dense on that one, but hopefully that helps anyways. I don't know. Come on, there we go. Cool. Let's see. I'm hoping I'm getting to everybody's questions. Oh no. Looks like I'm missing one here. Let's see. Didn't mean to skip over you. If I do miss somebody's question, I apologize. I'm trying to take in like field comments as we're talking about the problems, and keep track of which questions I have and haven't gone through, but I think I'm going to get them all. Okay, cool. So we've got this one, remove number value. Yeah. And this one comes with a runtime error. Dictionary change size during iteration. This is a good one. This is an interesting error. We will explore this. Thanks for including the error too. That's good. Okay. So dictionaries. Ooh, this is in the dictionary challenges. Number 17. Thank you for the number there. Go to number 17. All right, a function called remove number values. Given a dictionary, remove number values removes any key whose values are numbers. Oh, interesting. Good. So it gives us, fortunately, it gives us a little test here. Come on. All right, here's our runtime error. Yay. So let's read this code and then we'll get into this error. So we have our input, which is called int. That's going to be our dictionary. I'm going to just call this my int, just so we can kind of verbally, so I'll be able to more easily verbally distinguish between the two. So this dictionary takes in my imp, which it represents as imp. Imp copy equals imp copy. Then for key value in imp copy dot items, if the type of v in float or int, this is great. This is this is good. Checking if something is one of however many types. Then we're going to del this key from the imp copy. So check this out. Our error says runtime error. So what a runtime error is, it's not it's not complaining about the syntax. It's, if it was, then it'd be a syntax error. So a runtime error occurs when you have valid code. All this code meets the constraints and the rules and standards of the Python programming language. This is correct Python. However, we get an error during the running of the code, and it happens after the code has been checked for correctness, and whatever, and something occurs where the program is no longer able to function. The Python interpreter gets put in a position where it has to do something that it can't do, so it goes runtime error. So this says dictionary change size during iteration. Okay, so we have a dictionary that's being iterated through and it changed size. Here's our dictionary, which is int copy that we're iterating through, and here's it changing size. So it's easy to think, well, if I'm going to iterate through an object, then if I modify that object, then it's easy to make the assumption that the object being iterated through will not be altered, because I already said I want to iterate through that object, that dictionary in this case. You can get the same thing for a list too. So the reality is we told Python to iterate through a specific object and delete, during that iteration, delete from that exact same object. So what happens is we delete something from that object. What decision should Python make about what its next iteration should be? You know, the thing just shrank, so where does it go next? You know, and you might make an assumption about what it should do, but if you actually think about that problem, you'll realize that no assumption is really better than any other, and that there isn't really a clear objective answer to what it should do. And whatever it could do is complicated by the fact that it now has to add in additional, it would have to have the ability to navigate essentially something that is changing, which as it's changing, which if you can think of an objective way of doing that, even for a given assumption, that's great, but that adds kind of a lot of complexity to for loops, which are kind of simple things, right? So programming that in that ability for this to be robust against that would be a performance impact across the whole language, because for loops would need to be robust in a way, and they would need to run additional checks kind of constantly, and so rather than taking that performance hit, you just get an error, which I think is the right call in this case. So what we need to do is iterate through a different object than we modify. So since we copied here, I think what I want to do is just iterate through the initial input and modify the copy, since these are the same, right? So we'll iterate through the input and we'll modify the copy. We'll delete from the copy. So if I do that, that should work okay. So C says hi and there, and D says hi. And our expectation is C says a list of hi and there, and D says hi. Good. Okay, so this does work. However, there is a solution that I prefer even to this, which is I prefer in general, I prefer to construct solutions that are additive over subtractive. So when we're talking about accumulator patterns, I would consider this a kind of accumulator pattern, even though we're literally doing the opposite of the definition of the word accumulator. It's still what I would call categorically an accumulator pattern. Some people will call this a decrementation pattern, or yeah, I think I've heard it called a decrementation pattern. I will say there are times when it does make sense to like shrink something that does exist. There might be performance reasons why you would choose to do that. But in terms of just producing code that's just going to work and be robust, we can take a slightly different approach, and we can do an additive accumulator. So what an additive accumulator does is generally starts with something empty and then adds to it, right? If it's a dictionary or a list, it's going to be an empty dictionary list. If it's a number, generally it'll be 0. But generally, you start with something neutral. The definition of neutral is contingent on the details of the problem. So whatever that means, it may or may not have some starting values in it. But so you start with something quote unquote neutral, and then you add to it, right? So if we took that approach, if I said imp copy just equal to empty dictionary, and I wanted to add something into this dictionary, I would say imp copy sub k equals v, right? But I only want to add k to imp copy sub k, or I only want to add the value to imp copy at this key. I only want to do this if the type of v is not an interfloat. So all you need to do, if you've written a subtractive solution, you just need to take the negative case of whatever relevant conditions. So the negative case of type v in float or int is type v not in float. Oops. Not in float or int, right? So we just need to invert this condition, have it check for the opposite thing, just a nice easy modification. And if it's not a float or an int, then we want to add it in, right? And then this is going to accumulate all of the values, all the key value pairs where the values are not a float or an int, right? So the nice thing about this is we don't have to copy. We end up with something, we end up with a sort of a de facto copy, right? This is a different dictionary with a different ID, so we don't have to copy, and we don't have to worry about, oops, I said imp, we're iterating through, we want to iterate through imp. We don't have to worry about the object changing size during iteration. That's lowercase v, not capital V. There we go. Yeah, so you don't need to worry about the object changing size as you're iterating through it when you're doing an additive solution. Not as much anyways. So the other nice thing about this is this turns this from like reductive or subtractive code, which I generally find hard to reason about, into additive code, which, I mean, if you look at this, this is, to me, you may have a different opinion about this, but to me, I look at this and like, this is vanilla. Like, this is boring, which is good in general. Like, that's kind of a nice quality for code to have, to just be like straightforward and mundane. Like empty dictionary for KV and the input, if the type does or doesn't meet some criteria, do the thing, add something in, right? And then after you're done with that, return it, right? Like so many problems look like this, and this is just another one that we can make look like this. This might feel a little less exciting. I think I'm also not, this says remove values, so presumably they want you to use del or pop or something, I don't know, but so maybe I'm not really capturing the spirit of this of this exercise, but it does make for a simple, easy, and robust solution. It's simple and easy because it's, you know, like this pattern just kind of works for a lot of stuff. It's easy to reason about, it's easy to read and write. And it's robust because it's just it's pretty taking this approach leaves you pretty safe for not getting a lot of errors. So. It works. Okay. Cool. Hopefully that helps. The video is a little blurry. I'm sure I missed some little thing. Oh, I'm sorry. Yeah, apologies. Here, let me blow up the text in here. I think I turned down the text size because I tend to like it a lot smaller. Let's see. Getting the wrong number for index 1. Let me pull in your code here. We have a request to revisit one of the previous problems. Still throwing an error. Let's just take a look at this for alt series. Oh, maybe did I not submit this? Oh no, I did submit this. Okay. Number 2. Huh. Yeah, let me try this again. Let's see, I'm not sure how that's really different than the code that I submitted, but we'll see. See if this gives us anything. Oh, I see. Is that what's happening? That is what's happening. So what's happening here is that these are outside of the for loop. These are not inside the for loop. So notice the indentation level of these is equal with the for loop. It's indented equally as far as the for loop. The way Python knows to like stop some process is once it sees code that is unindented from that process. So it knows that this for loop is over by finding code that is unindented from it. So the for loop was running and doing alt sum, and then after the for loop was over, it would just say pow sum equals num to the idx and index sum equals idx to the num. So we just need to tab those in, then I think it'll work. So let's try that and learn. Yeah, it looks like that works. Ah, cool. Somebody got to it before I did. Okay, good. Thank you. It's good to go over it anyways because, just like as a reminder to watch your indentation because it's a real thing in Python. So as annoying as that can be, but I can say you definitely get used to it. I've worked in languages that have brackets, instead of white space formatting, they have bracket formatting. And I gotta say, I do prefer white space formatting. It's so clean. It just makes nice, pretty, easy to deal with, easy to read, write code. But it takes some getting used to when you're first starting, for sure. Cool. Okay, cool. I'm not seeing any new questions. Oh, it's been almost an hour and a half. Maybe we have time to go through something. I know we got a little bit of a late start. Oh, here we go. We do have a new question. Let's go over this. Not trying to take over, no worries. We don't have any questions on the stack right now, so I'm happy to take anybody some questions who's got a question. So appreciate the engagement. Okay, number 3 in what is an accumulator? And we've got some code. Presumably this is the code. Real quick. Yeah, okay, so stir is a built-in function. When this says returns stir, this really, I always like to do this because it makes, I don't know, to me I read this, there's a different language that I write in sometimes that uses that as like explicit type annotation, but stir is actually a type specifier that's built into Python, so you don't want to use that as a variable name. You can, however, say string. Oops. String. Yeah, we'll get to that in a second. So let's just pop this into the old editor and complete the accumulator. Okay, this is hardly even a, what is this? Complete the accumulator function below according to its docstring. Okay, the docstring is the thing. Returns an object that is accumulated as a result. Whoa, dyslexia. Returns an object that is, oh, come on. Returns the object that is the accumulated result of chars. Chars is our input. Okay. Parameters. Chars. A list of chars. Well, that's a good thing. Returns a string. The accumulated version of the elements in the list. What? Returns an object that is the accumulated result of chars. Okay. I guess we'll just do, I think they just want to make us do a string accumulator. We have a list of strings, and I think what they want us to do is just say string equals empty string, chars equals chars. So we don't want to mute or change chars inside here, right? Because that'll just override whatever we put in as the input. So let's do, we'll just call this my chars, and we'll print. So I'm starting with the test. I'm writing the test for the function. We'll print accumulate, and accumulate will take as its input my chars, a list of stuff. And so we have our string. This is our accumulator target. And then we'll say, so real quick note here, if you have a return that will be encountered, that like will absolutely be encountered, like no matter what during the iteration, you're only going to get one iteration out of your loop, because when your function encounters a return, like it stops executing code in the function. It outputs the return value, and that's it. It is done running code inside the function. If it's in the middle of a loop, it stops the loop. If it's in a condition, it's just going to return whatever. If there's code below it, it doesn't get executed. The loop is over. So what we want to do is return on the same level as the for loop in this case, outside the for loop. To be clear about this, sometimes you will have a return inside of a condition inside of a loop. So sometimes you'll see that, but if there's a return that's ever nested inside of a loop, it only makes sense to nest that return in a condition and nest that condition inside the loop. Because there's certain scenarios where you're looping through something and you check a certain condition, you find something is true, and you're like, well, I don't need to check any more conditions, I already know what I need to return based on this. So sometimes you can get away with doing that, but in this case, we don't want to have just a imminent return. I always feel weird saying it that way, but that's kind of how it makes sense to me. So, okay, so this will say for item in chars. Then we'll say string. We want to accumulate. We can use plus equals item. And oops, this said, oh, here's another sort of tip for variable naming. Things that are collections of things, lists, tuples, sometimes strings, usually like lists and tuples, dictionaries, often can be named with a plural name, so chars is plural, right? When you're iterating through them, what you're usually getting out, and in this case what you're getting out, is a singular, right? So for item, I understand where this comes from because in English, this is more grammatical, right? Like for items in chars, right? So for the items in the chars list, right? To make both of these plural, although it tends to make more sense in Python to make this singular. So for the item in the collection chars, string plus equals item, right? So it just sort of makes it more semantically easier, I think. So, good. Let's try this out and see what happens. A list of stuff. This doesn't have spaces in it. I'm not sure. I don't think this said to put spaces in it. So I think I'm just going to try this. If it complains or it shows me it expects an output that has spaces, then we'll put spaces in it. But I suspect this is going to work. Yep, it does. Okay. It looks like their code is the same, just different variable names. So phrase equals an empty string for C and chars. Phrase plus equals C. Cool. We could, so this is the accumulator approach, which is what we should do because this is a lesson on accumulators. There is, however, a shortcut. We could say string dot join chars and just do that. This would also work. If I actually had to do this, this is, you know, like if there was a scenario where I had to actually write this code, that's what I would do. It's a little bonus for you. But that is not what's being asked here. What's being asked is what's being asked for is specifically an accumulator approach. And I think the spirit of this is to get you familiar with just basic string accumulation. So okay, so we have a question. So is plus equals better than append? So if we look at this, our accumulator is a string. You're not returning anything in the code that you sent. But our accumulator is a string. The type of it, it's also called string, but the type of it is a string. Strings don't have an append method. So the append method only applies to lists. The only thing that has an append method is a list. If this were a list, then I would say you should use append. Since we're using a string, you can use plus equals. Plus equals will actually work in most cases for lists as well. Plus equals will work for strings, lists, and tuples, but although there's some ins and outs you have to know about that as well. So I would say if you're working with a list, use append, but for other things, it's strings. Yeah, or it's plus equals. Yeah. Cool. Also, did you get what I was saying about the code not having a return? So real quick, I'll paste in. I think there's a little bit of a delay between when I say something and when y'all hear it. But so just to juxtapose these against each other real quickly, right? We have string equals empty string. We have for item and chars. We have string plus equals item. And then my code has return string, and the code giving an error just has return. So we do need to specify what we want to return. Cool. Awesome. Good. All right. All right. Well, that puts us about at time for today. So I think we can wrap up here. I appreciate all the engagement. I appreciate everybody's bringing in questions. I think that's what makes study halls useful and good. Yeah, I appreciate everybody coming in and hanging out. I find these to be a lot of fun. I hope y'all do too. Definitely feel free to DM me, and if you have any suggestions, helpful criticism, whatever, I'm open to whatever. I know the mic is bad, and I know the video quality is bad. I'm working with kind of weird bandwidth. I don't know why the bandwidth is so weird on this computer. I think it's also just sort of a RAM limitation. But I will be upgrading my computer within the next few months, hopefully. Hopefully fairly soon I'll have a new machine that'll be more up to the task of streaming, and we'll get better streaming quality. So definitely, please feel free to let me know, if there's any fidelity or quality issues with the stream, for sure, or any other issues as well. Yeah. All right. Well, I guess without further ado, it's been a pleasure. And if you're coming to Premium Prep, I'm teaching tonight, so I'll see you there. And if not, then if you're coming to next study hall, that'll be on Tuesday, and I'll see you there. So yeah, bye-bye.